Hey, Integrated 3 students. So today we're going over two things: subscript notation for iterative functions. The fish pond population problem was an example of an iterative function relationship that we looked at. So here is an example of what subscript notation looks like. In class, I gave you an example of, let's say that every year, I lose half the money I have, and I also get $200. So as the year goes on, I spend half my money, and I also gain $200. The next now function for this situation would look like this: 1/2 times now plus 200. So what that means is I'm taking a half of the money that I have now, so however much money I have right now, I'm dividing it in half, and then I'm adding 200 to determine how much money I have next. So this is how we wrote this earlier this week. However, we're going to move away from using next now functions into using subscript notation. So I'm going to do an example of how this next now rule would look using subscript notation. And I'm going to use an uppercase M to denote money, stands for money. And I'm going to write parts of the same function, but instead of next and now, we're going to put something else. So subscript is when you write something in the lower right-hand corner of a letter. An exponent is up here. If you wrote a number right here, that's an exponent. That's not what we're talking about. Subscript, like subway, it's down below the letter. So in this case, I could use subscript notation to write the same rule. And the way I'm going to do that is I'll put M, so the money that I have in this year, for any year, I'm going to denote with an N. So this is saying however much money I have in the nth year, so any year, I'm going to divide it in half or multiply it by a half, same thing, and I'm going to add $200. And that will give me how much I have in the n plus 1th year, so the next year. So for example, if I was doing the second year, this n would be 2. So I'd take half of the money I have in my second year, add $200, and that would give me how much money I would have in the 2 plus 1th year, which is the third year. So this is subscript notation. And one of the problems you do today is going to take the next now rule that you created in the fish pond problem, and you're going to write that next now rule with this kind of notation using subscript notation. Okay, next up is spreadsheets. So you're also going to be using spreadsheets to solve a problem today. So let me open up a Scratch spreadsheet, and let's talk about spreadsheets. So I want to model the same scenario that I mentioned on the Jamboard. And that scenario is starting with a certain amount of money, dividing it in half, and then adding $200. So let's say I'm starting with $1,000. I'm putting $1,000 in cell A1. So I said A because we're in column A right here, and we're in row 1. You can see A and 1 right there. So I need to write a formula in Google Sheets, and you're going to be using a formula to answer some of the questions in today's classwork and homework. You always need to start a formula in Google Sheets with an equal sign. So I'm going to type an equal sign. And then let's say I want to do the same money formula that I did before. So I'm going to do 1/2, which is 0.5, times, and now instead of writing M sub n, or the word now, I'm going to write a cell reference to my starting amount of money. And the cell reference to my starting amount of money in this case is A1 because the amount of money I'm starting with, $1,000, is in column A, row 1, cell A1. And you can see that when I type A1, it makes that cell orange. And the letters are A1. Letters and numbers A1 are orange. So that shows that I'm referencing the right cell. So I have equals 0.5 times A1 plus $200. So if you look at my cell, when I click in the cell, you can see the formula. Equals 0.5 times A1 plus $200, and that result gives me $700. So here's one of the really nice things about Google Sheets, and one of the things that you're going to need to use to answer some of the questions that you have to work on today. When you write a formula like this, Google Sheets knows that you are referencing, when you're referencing cell A1, that's the cell that's directly above the cell that your formula is in. So in Google Sheets, if you have a reference like this, A1, what Google Sheets can do, well, you can click on this little, so if I'm highlighting this cell, you can click on this little blue square in the bottom right-hand corner of the cell, click and drag down. So I clicked, I'm dragging down to like row 25. And if you double click in another cell, so here, for example, this first cell is the original formula I typed, and it has A1, because that's the cell that's directly above the cell I'm currently typing in with the formula. Let's look what happens if I double click on this cell. Now it says A2, because it's referencing the cell that's above this cell. If I double click in this one, now it says A3, because it's referencing the cell above this one. So Google Sheets lets you perform iterative calculations really easily by using this functionality. So again, once you have a formula written, so I started with A1, which is the cell directly above this cell, you just need to click on this little blue square, click and then drag down, and it will fill that formula in and let you see the value that you get 25 steps further down the line. So in this case, this would be 25 years farther down the line. So you're going to be using this for a couple questions in class today. So use Google Sheets to solve the iterative function questions that you have in today's asynchronous work and today's homework.